So this is a simple machine that I've modelled up in SolidWorks. I've modelled up these beams with multiple mounting points or multiple pivot points along their length. That's just to allow me to experiment with the setup, so I can vary the lengths of the levers by moving the pivot point or moving this connection point between the two beams. So modelling those up is relatively easy, and then I've dropped them into an assembly. I've also modelled up just a block of material here, so that acts kind of like a base, just to anchor the thing. I've put a sketch in here that I'm using to define how high this beam is kind of located above that block, so I've just put that straight into the assembly. You could actually model up a shape to this block that was kind of like an A frame, so you could add material to that block until it was this high, and then you could cut a hole through that block and it would perform exactly the same function that this simple sketch is performing. It's just for speed or for ease of setup, I've just created a sketch line. But yeah, if you were building this machine in reality, you'd probably turn this block into some kind of A-frame to support this this pivot point. So yeah, there's two links in there. They're joined together using appropriate mates. If I just kind of drag those around, you can kind of get a sense of what's happening. There is actually another line that I've put in here, and that is to allow this part to have something to point at, essentially, because when I take these parts through into motion simulation, I'm going to simulate the effect of having kind of a spring attached here and down here to the block. So that's how I've set them up at the moment. So if I just have a quick look at the mates before we go through into motion simulation, so let's have a look at the mates in here. So there's obviously a concentric mate between these two parts here. Then there's a coincident mate between the two faces of the parts, just to hold them in position. And then the last mate that I've put in is between the plane in here and that point at the bottom of that sketch. So that's one of the things that sketch is doing. It's just giving this plane something to point at or something to be coincident with. And that has the effect of, as this larger link moves, this link kind of points at something down here as if it was anchored to that point using a spring. So that's the broad setup of the assembly. And then I've gone through into SolidWorks Motion. So I'm just going to switch the full SolidWorks Motion add-in on. So I'm clicking on there. The add-in will become active. Then I've gone through into a motion study, and I've set the type of study from basic or just animation to full motion analysis. And then I've done some setup in here. So I've put a linear motor in here. So if I edit the linear motor, the way that you add linear motors or rotary motors is that icon there. So I've made it act on this face here as if there's some input force that's been transmitted through that face. You can see the direction of the linear motor. So the way I've specified that direction is to pick the top plane in the assembly, or maybe the top plane in the block, but one of the top planes is defining the direction of that force, so that force is acting normal to the plane. This third box, I've given it a part to move relative to. So all of these parts have an X, Y and Z direction internally inside them. The assembly itself has an X, Y and Z direction as well. You can see that down at the bottom left hand side here. But what you can do, if you're specifying particular directions, you can pick a part that you want that direction to be relative to. Then I've selected oscillating motion, as if this face is being pulled downwards and then pushed upwards and then pulled downwards again and then pushed upwards. I've given it a distance that it has to move through. I've given it a rate of oscillation of 0.1 Hertz. and then I can offset the kind of starting point on my graph of maximum movement one way and then maximum movement the other. I haven't done put any offset in there or any phase shift at all. So that's the motor setup that I've put in. I've also created a linear spring, so there's the linear spring icon if you need to create one. So if I have a look at how the linear spring is set up, the linear spring is actually simulating a spring which is anchored to this point here and this edge here. I think I tried to anchor it to this point here, but the system wouldn't allow me to do that. Let's see if we can modify that slightly. So we'll delete that edge, see if we can anchor it to that point. We actually can, so that's more realistic. So the mate is kind of pointing this link down towards that point in that sketch, and now this virtual spring that I'm specifying currently is also anchored there, so that's more realistic. So the spring is a linear spring. Steel springs tend to be linear unless they have special windings. Air springs tend to be progressive. So a linear spring is easy to specify. You just need to specify a number of newtons to compress it a given length. So it's newtons per length or newtons per millimeter. So I've given it 1 newton for every millimeter it gets compressed. I've specified a free length. So this is, if you imagine a steel spring just laid on the desk, this is the length that it kind of relaxes to. It's free length before it's being compressed or extended. So obviously in the model setup you could define what the free length was. You could use the measurement tool to kind of measure the distance between here when the machine is at rest. I've specified an approximate free length there, and then this bottom setup is just how do we want the spring to be displayed in the display window. It doesn't really affect anything. If we want to play around with this now, you can see the display of the springs changing slightly. That's just a representation of the actual spring. It doesn't really affect anything. It's just editing the graphics there slightly, so you don't really need to bother too much with that. You can see I can add as many coils as I want in there, but the actual physical setup of the spring is here. That's just the display. So I've created those two things, and then you have to calculate the study to get the system to kind of calculate how they will work, those two items. So you can see the oscillating motion is kind of happening. It's going backwards and forwards. It's oscillating. One thing that I didn't mention was this little black kind of diamond here. You can click and drag that to any length, and that defines the overall length of your study. And I believe when you set these studies up, they're all set at 5 seconds by default. So I've dragged that up to 15 seconds, just so that my oscillation has chance to reach its maximum at either end, and then kind of a little bit extra as well. So I've set that to 15 seconds. So that's the simulation created and calculated, but then we can graph certain quantities. So if these graphs will work in here, which they did do earlier, but sometimes they don't show themselves. Yes, I think it's because I've got a multi-monitor setup here, so they kind of appear on one of my other screens. So let's try and arrange the screen here so that we can kind of see these two graphs. And then we're going to run the simulation and watch the points on these graphs as they relate to the simulation. So here's the simulation. One other thing that I probably should have said is the default setup for motion analysis is that wherever your camera happens to be when you begin the analysis, even if you move your viewpoint, when you rerun the analysis it kind of snaps back to the angle that you were viewing the part from to begin with. When we're running these simulations, that's not terribly helpful. So what you do is you right click here and you click disable playback of view keys and disable view key creation, and that should allow you to kind of manually set the angle that you view things from. So let's just play this simulation. I haven't actually disabled that option that I said. So disable playback of view keys, and now I should be able to play this thing. So you can see it playing, and you can also see there's a line on these graphs that's kind of tracing along the graph relative to where we are in these 15 seconds of time. So what are these two graphs showing? Well, one is showing a linear displacement. So I've set one up to, so if I drag this bar back to a certain point, so if we look at the linear displacement graph, it gets to a minimum there. So I'm basically measuring the movement of this face here in a vertical sense, so in the y-axis. So that's what this graph is graphing. So before this machine begins moving, what position is it in? It's there. So that is 590, I think, above the top plane currently, that face. And then as this simulation runs, that moves in a downwards motion, and that measurement actually increases. But if we were to take this number minus this number from it, that is the travel that our little face there is going through. So that would relate to the linear motor setup. So we can graph faces or points on this machine and find out how they are moving. How do we set that graph up? So that is plot 1. So we'll have a look at plot 1. The way that you create graphs is this icon here, results and plots. And in plot 1, here's the setup. So I'm just going to hide plot 2 just for a moment. So what do I want to plot or graph? I want to plot a displacement. You can see all the different things that are available to plot. So displacement is what I'm interested in. It's a linear displacement, just in a certain direction. It's the x component, but we'll come back to that in a second. Where am I plotting it? Oh, it's not actually over here that I've plotted. It's actually this link here that I'm plotting the displacement of. So I'm plotting the displacement of that little point there on the link. How does that move during the stroke of the machine? So it's that little point, and what am I plotting it relative to? That point there. And in what direction am I interested? In the x direction, so this is the x component here that I've set. But when I say the x direction, I mean relative to the link itself. So that could be relative to the block, and x means something different if I relate it to the actual block down here. Let's see if I can relate it to the overall assembly itself. Yes, I can. So that would be, x would be in that direction. So x can mean, or y or z can mean various things depending on which component you're relating it to. So you can pick the component that you're talking about when you're saying x or y or z. So let's put it back to the link. So I'm plotting how this link moves in x as the overall machine moves. And then when you've set all this up, you just click on the tick and you'll get a graph created. And then as you play or as you move around in your simulation, you will see the value graphed on the plot that you create. So that's plot 1, to do with displacements of various things within the machine. Plot 2, if we show plot 2, is plotting a force. So you can see it's plotting something in newtons, which if we run it back to the start, there's a difference here of 166 newtons. So its minimum value is -1, its maximum value is 165. So there's a range there that it's going through of 166 newtons. And what does the setup of this one look like? What is that actually plotting for us? Well, it's within the forces kind of subsection. It's not a displacement or a velocity or an acceleration that we want. It's a y component, but what is that relative to? It's actually relative to the block. So let's see if we can set this up again. This is it. So I kind of broke the plot there as I was playing around with it. So it's within the forces subsection. It's a motor force that we're interested in, because if you remember, we've applied a linear motor to this face here to kind of pull it downwards and then release it back up again, and then pull it downwards and release it back up again. So we're getting a readout of how much force that motor is having to exert on our machine to overcome this spring that we've put at this side of the machine. So it's giving us an indication of, let's say a human was pulling down on here, how much force would a human have to pull down at the end of the stroke here, because there's a spring resisting what they're doing there. So it's a motor force that we're kind of mapping or plotting. It's in the y direction. When we say y direction, what is that relative to? So what is it relative to? The block at the bottom here. So it's y in that direction that we're interested in. And in this box, all it asks us to put in there is the motor itself. So all I did when I put the motor in there, so imagine the box was empty, I just found the motor down here, there it is, linear motor, and I just clicked on it. Simple as that. And then when I click on OK, I get the plot there. So yeah, that's how to create plots, how to set up motion simulations, and how to plot certain values on a simple machine, and how to insert motors and spring elements as well, so that you can kind of build a simulation of a simple kind of linkage machine like this.